Good morning, students. This is your RJ sir. Today we are going to discuss FAJANS rules, very important for objective point of view in IIT JEE and also in NEET exams and also MSET, that is TS and AP MSET. I will explain clearly what type of question will come, what is the importance of FAJANS rules, and formation of ionic bond and covalent bond. What is the relation? We'll discuss today. Without wasting time, we'll start the class. Yeah, see all of you. So Fajan's rules, the name of the scientist, is given some rules for us to understand how ionic bond and covalent bond is formed. How ionic bond and covalent bond is formed. See all of you concentrate here. See this. So Fajan's rules. We are discussing Fajan's rules here. So, what are the FAJANS rules? These are useful for favorable conditions, favorable conditions for the formation of ionic bond, and also covalent bond, ionic bond and also covalent bond. So, what are the favorable conditions for the formation of ionic bond and covalent bond? Okay, students. Yeah, we'll discuss now. First of all, here concentrate what are the properties we required. What are the properties we required for the formation of ionic bond and covalent bond? So I made a simple and logical and points to understand when ionic bond is formed, when covalent bond is formed. Okay, clear? Now you can see your first property we'll discuss it. Property. What is the property? Atomic size. Atomic size is a property and is a factor on ionic bond and covalent bond based on our Fajan's rules. Which rules? Fajan's rules. You see what are these? So for atomic size, we'll go for here. For example, cation. I took here cation and anion for ionic bond. Similarly, for covalent bond, I selected here what? See this here cation and anion. For both, for ionic bond also we are discussing cation and anion, and covalent bond also we are discussing cation and anion. Clear, student? Yes. Now you see what is the factor of atomic size for ionic bond. Atomic size for ionic bond. See what is tabular form is shown here. For example, atomic size for ionic bond, cation, cation, cation atomic size should be large. That should be what? Large. That should be large. Whenever atomic size of cation is large and followed by a anion atomic size should be smaller. Smaller. That should be small. Whenever cation ionic size large, anion ionic or cation size ionic size is smaller, then it is leads to form ionic bond. It is leads to form what? Ionic bond. And we can discuss about covalent bond. Opposite of this one. Cation size is smaller when compared to anion. When compared to anion. Then what happens? Then these two means small size of cation, large size of anion, both combine and form what? Covalent bond. Covalent bond. That is a combination. So with respect to atomic size. With respect to atomic size. Now one more property is very important property is IE. IE means ionization enthalpy. Ionization energy and followed by electron negativity. This is electronegativity. That is ionization energy for cation, electron negativity for anion. Electronegativity for anion. So now see here for cation here IE value, ionization enthalpy value should be low. Ionization enthalpy should be what? Low. Then for anion, electron negativity should be more high. This combination leads to form ionic bond. This combination leads to form ionic bond. Clear, student? Now, for covalent bond, opposite of this one. See here for cation, here IE value should be more and En value should be less for anion. Then this combination leads to form covalent bond. Covalent bond. Now, next one is very important. Next one is charge. We'll discuss clearly about this charge. This is very important, and there is so much confusion. Okay, I will explain clearly today. Now, here charge, both cation and anion, both should be low charge. Low charge. Both cation and anion should be with a low charge. Then only favorable to form favorable to form ionic bond. Favorable to form which bond? Ionic bond. So cation charge should be low and anion charge should be low. Then both are low charges. Then that is favorable to form ionic bond. Clear? Now you can go for your covalent bond. Here high charge. Here both should have high charge. High charge of cation and also high charge of anion. That leads to form here what? Covalent bond. Covalent bond. Clear, student? That is the importance about this. And last but not least, inert gas electronic configuration. Inert gas electronic configuration. So that is here compulsory. This is compulsory for inert gas electronic configuration, noble gas electronic configuration. Every cation and anion must possess inert gas electronic configuration before participating bonding. That is ionic bonding. Clear? So before bonding, everybody should be stable. Isn't it? That is the concept here. But here covalent bond, there is special point is there. You can see all of you. What is this? So for covalent bond, cation must possess pseudo inert gas electronic configuration. What is pseudo? I will explain later. Okay. What is pseudo? I will explain later. Pseudo means here generally false. False inert gas electronic configuration. That is not real inert gas electronic configuration. Then that cation, it leads to form your covalent bond. And here anion must possess inert gas electronic configuration. These are all are here FAJANS rules. Clear, students? These are here what? FAJANS rules. Once check it out again. Atomic size for cation large, anion smaller, ionic bond. Here opposite, cation smaller, anion large, covalent bond. Here ionization enthalpy for cation low, electronegativity for anion high. Here opposite. Clear? Now charge, both should be have low charge, leads to form ionic bond. Here cation should be high, anion also high, then leads to form covalent bond. And last one, inert gas electronic configuration. Here, inert gas electronic configuration, every cation anion must possess inert gas electronic configuration before participating in chemical bonding. But in covalent bond, cation must possess pseudo inert gas electronic configuration, but anion should be inert gas electronic configuration. This combination leads to form ionic bond and covalent bond. Okay, I will explain here one more important concept here. You see, why sir atomic size is favorable for that? Why atomic size is favorable for that? Any reason? Yeah, I will explain clearly. All of you listen. See, for example, I am taking sodium. What is this? Sodium. This sodium atom contain here what? Na plus atomic number 11. So removal of one electron, it become what? 10 electrons. How many electrons? 10 electrons. Now this is here valency cell. So this is the radius of electron. So valency electrons, removal of one electron, what again? Atomic size should be here 11 only, but number of electrons are 10. That is equal to inert gas electronic configuration, that is neon. So that is stable cation. Stable cation. So now whenever we have, see, we need to remove electron from valency, that radius should be large. When radius should be large, then nuclear attractions are less, then easily we can remove electron from this valency. That is nothing but low I. Low ionization enthalpy required. Yeah, that is possible because whenever atomic size is large, then easily we can remove electron from this. That required low ionization enthalpy. That's why large atomic size is favorable. Clear? When large atomic size, charge also low, that is plus 1 is there. So we can remove electron easy because size is bigger. Now this process inert gas electronic configuration. See, it passes inert gas electronic configuration. Clear, student? So that it is favorable for the formation of cation. That cation leads to form a ionic bond. What about anion, sir? Yes, anion also will discuss. See this anion, atomic size of anion. See, this is fluorine, atomic number 9. Addition of one electron, it becomes 10. That is also equal to what? Neon electronic configuration, that is 10 electrons. 10 electrons. Now, so the radius of this one compared to this 9 protons, there 11 protons. So 9 proton means the radius is smaller. Radius is smaller means we cannot remove electron, but it attract electrons. That is nothing but it has more electronegativity, more electronegativity and non-metal. So atomic size is smaller. Due to smaller atomic size, it has more electronegativity and low charge and inert gas electronic configuration. Therefore, it is favorable for the formation of anion. This anion leads to form ionic bond. Leads to form what? Ionic bond. Now we'll go for general example. Is it correct examples? Are they satisfied this compound? We'll discuss first. Yes. Before going to this, you see, I given one best example. That is what? Sodium fluoride. And one more is sodium chloride. Both are given. What is my question here? All of you concentrate. Sodium fluoride, both are contain sodium. Both are contain sodium and sodium. Yes, these sodiums are 11 electron. This sodium also are 11 electron, 11 protons. Now, fluorine 9 atomic number 9 protons, but chlorine it is 17 protons, 17 electrons. Clear? Now you see sizes of this one. This is the cation, this is the anion. Here cation size is large, anion size is smaller. So now you can see just now according to FAJANS rule, atomic size which is favorable, cation should be larger, anion should be smaller. Yes, here in sodium fluoride, you can see in sodium fluoride, that is a possible. Cation size is large, anion size is smaller. Now here sodium chloride, you well-known compound is. Here this is the cation, this is the anion. Now tell me which is ionic compound, whether sodium fluoride. You tell me which is ionic compound, whether sodium fluoride is ionic or sodium chloride is ionic. So according to your knowledge, as per Fajans rules, this is ionic, this is not ionic. So more ionic, this is less ionic. This is less ionic, this is more ionic. That is the importance of Fajans rules. Both are contain metal and non-metal combination. Both are contain metal and non-metal combination. That is not matter here. So according to Fajans rules, which has more big atomic size, which has small atomic size, cation has large atomic size, anion is small atomic size. Therefore, this combination will give you more ionic nature. This is ionic compound. In the case of sodium chloride, here cation is smaller, anion is big. You can see here. See, just now I given. So cation is size is less, anion is more. Then we need to see that covalent nature is more, but ionic nature is less. So when compared to sodium fluoride and sodium chloride, which is ionic? Yes, sodium fluoride is more ionic. Sodium chloride is less ionic according to our Fajans rule. I'll give one more example for you based on this. You can tell me answer. What is that? Which of the following is more ionic in nature based on the Fajans rules? Tell me. Yes, see the question, all of you. Concentrate. I given potassium fluoride, potassium chloride, potassium bromide, potassium iodide. I am asking more ionic in nature. More ionic in nature. Yes, you can comment this answer here on this page. Okay, that is your question. Clear, student? And before going to that, I will explain what is charge, sir. Why should we take here low charge? That is not your doubt. Yes, yes, I will explain about this. Why we are taking low charge, low charge? When both are low charge, how it is possible? That is your doubt. I know. I will explain clearly with the low charge of cation and low charge of anion. All of you concentrate here. All of you concentrate here. I will explain completely. Yes. See this? I am taking low charge of cation is more favorable. Why? Why low charge of cation is more favorable? Why only low charge is more favorable? We'll discuss. I took one example. Cation, aluminium, atomic number 13, atomic number 13, number of electrons also 13. Now, I removed one electron from this. I removed one electron. It becomes what? Al0 to Al plus 1. Removed one more electron, Al plus 2. Removed one more electron, Al plus 3. See, we can remove electrons from the atom. What happened? Yes, what happened? You see here. So this is here 13, 13. I take one best example to understand this. 13 boys are inside. You can feel that. And 13 girls are outside. You can feel that. Yes, this is negative charge, this is positive charge. Clear? What happened? This is balloon. Now these people are, yes, outside. They are pulling outside, right? And inside how many boys are there? How many boys are there? They are pulling inside this balloon. This is the balloon. What happened? See, inside 13 boys are there, na? The 13 boys, outside 13 girls. Both are equal. 13 here 13. Both are equal. Then size is not changed. When we can remove an electron, one girl is reduced. That is here we can see only 12 girls are there, 13 boys are there. Means the force inside is increases, then outside force decreases. Similarly, removal of one more electron, 11 girls are there, boys are constant. Therefore, force inside increases, force outside decreases. And we can remove one more electron. See this again, 10 girls are there, 13 boys are constant. Force outside, force outside decreases, force inside increases. When force inside increases, what happens? The size will be decreases. That is a nuclear charge means. See that nuclear charge, what happened here? All of you concentrate. Nuclear charge 0 to 1, 1 to 2, 2 to 3. This is called nuclear charge. So when nuclear charge increases, atomic size what happens, student? Atomic size decreases. Atomic size what happens? Atomic size decreases. When atomic size decreases, atomic size is required more energy to remove electron from that. So which is favorable condition? Large atomic size is favorable condition. From aluminum we can remove electron easy, but not from Al plus 3 because small size and it is more stable also. So that all of you concentrate here. What we are discussing, all of you concentrate. The atomic size, all of you see this. Atomic size or ionic size decreases, nuclear charge increases. Nuclear charge increases. So that at low charge of cation, see this. This is low charge, 0. Here high charge, 3. At low charge of cation, atomic size is larger. Atomic size is what happened? Larger for the cation. Therefore, liquid less IE and more readily form cation. More readily form cation. Therefore, we are selecting low charge. Low charge is favorable. At low charge, atomic size is more. IE, ionization enthalpy, IE is less. These two conditions are more favorable for the formation of cation. That cation is participating in a ionic bonding. Similarly, we'll go for here anion also. We'll discuss anion. Why low charge of anion? Yes, cation low charge, okay, that we can understand. What about anion, sir? Anion also low charge? Yes, that is also more favorable. You see, all of you concentrate here. All of you concentrate here. How low charge is? I'm taking different example here. I'm taking fluorine, oxygen, nitrogen, and carbon. So all of you concentrate this one. Yeah, I took here three different examples. So here fluorine minus 1, oxygen minus 2, the nitrogen minus 3, carbon minus 4. Different atoms I took and charges are changes. See here, whenever we can see charge on the anion minus 1, minus 2, minus 3, minus 4. Clear? Now what about charge? Negative charge increases. When negative charge increases, addition of electrons increases. What happens you say? Here, fluorine 9 protons, oxygen 8 protons, nitrogen 7 protons, and carbon 6 protons. Protons means nuclear charge. This is. See what happens nuclear charge here? Atomic ion size what happens increases. That is increases. Then nuclear charge what happens? decreases. Nuclear charge means proton, student. Don't forget. Proton in terms of nuclear charge. Because in nucleus, protons are present. Outside the nucleus, electrons are present. This is called nuclear charge. See, nuclear charge in this all atom. First one 9, 8, 7, 6. Whatever nuclear charge decreases. When nuclear charge decreases, when nuclear charge decreases, what happen you see? Number of electrons, here fluorine minus 1, addition of 1 electron, 10 electron, 8 plus 2, 10 electron, 3 plus 7, 10 electron, 4 plus 6, 10 electron. Number of electrons are same, but you can see the comparison. Here 9, 10, 8, 10, 7, 10, 6, 10. See the difference. See the difference. So here number of electrons are increases, but nuclear charge what happen? Decreases. Therefore, the low charge, you see, that is fluorine. At low charge, which is smaller size here? Which is smaller size? See, here 9 boys inside, 10 girls are outside. You can see this. Okay, I will explain again that. Here, all of you concentrate here. I will take that same example. You can understand easy what is going on here. Yeah, I am taking like this. In the case of fluorine, 9 protons, that is boys, and 10 girls outside. See what happened? Outside force is more, inside force is less. Inside force what happened? Less. Therefore, size what happened? Increases. When compared to carbon, you can take protons are 6, electrons are how much? 10 electrons are there. You see the difference here is 1, here difference is 4. So that, so atomic size what happen? Increases. Atomic size what happen? Increases. So C minus 4 is big atomic size and F minus is small atomic size. At small atomic size, your charge is minus 1, charge is minus 1. At low charge, charge is minus 1 and ionic size is smaller. Therefore, nuclear attraction is more electronegative, therefore more favorable for the formation of anion. Therefore, low charge. At low charge, smaller size. First point is smaller size and most electronegativity. These two conditions are favorable for the formation of ionic bond. Favorable for the formation of ionic bond. Got it? That's why. That's why both cation and anion compulsory required low charge. Low charge. This is the main importance about FAJANS rules. Clear, student? So that is a today's class. Thank you very much, and don't forget to don't forget to subscribe my channel and and listen more number of classes and attend more number of classes. And thank you very much.